Picture a shopper in Paris peeling the plastic off a brand new high-end smartphone. Now imagine a different scene. A customer in a London boutique admiring a hand-stitched leather bag, or a buyer in New York selecting a hand-woven carpet for their home. Beyond the Made in India label, these products share a specific origin point. Both the cutting-edge electronics and the traditional artisan crafts originate from specific districts within the borders of Uttar Pradesh. Historically known for its vast agricultural output and massive population, Uttar Pradesh has transitioned into an active engine of global trade. Only a few years ago, the state's role in the global market looked very different. India was a heavy importer of electronics, bringing in millions of mobile phones from abroad just to meet domestic demand. That trajectory shifted with a targeted economic strategy under Chief Minister Yogi Adityanath's administration, which set a mandate to turn the state into an industrial export powerhouse. This strategy involves two distinct engines of growth: a massive push for futuristic global electronics manufacturing, alongside a revitalized focus on the state's centuries-old local crafts. The first engine is centered in Noida and Greater Noida. This region has become the state's high-tech epicenter, attracting global giants like Samsung and Dixon Technologies to set up massive operations. This industrial growth is tied to a specific rollout of logistical infrastructure, including the Yamuna Expressway and the upcoming Noida International Airport, which provide manufacturers with direct air cargo access to the world. Within these factories, thousands of technicians work in sterile conditions on production lines that can output a finished device every few seconds. The assembly process marks the convergence of a global supply chain. Processors arrive from Taiwan, and displays are shipped in from South Korea, all meeting on the production floors of Uttar Pradesh. Surface mount technology machines rapidly populate circuit boards with thousands of microscopic parts. These are followed by automated optical inspections and digital testing to ensure every device meets international standards before packaging. By establishing this centralized infrastructure, the state has captured the final critical step of the technology supply chain, ensuring these devices are ready for immediate global export. Away from the sterile electronics labs, the second engine of the economy operates on a decentralized, local scale, utilizing traditional workshops found across the state. This sector is organized under the One District, One Product, or ODOP scheme. This policy framework identifies a specific craft native to each district and provides the commercial support needed to scale it for the global market. In Kanpur and Agra, the focus is on the leather industry, where generations of workers have refined the process of turning raw hides into premium footwear and exports. The strategy extends to the intricate woodwork of Saharanpur and the traditional brass forging of Moradabad, products that now reach consumers far beyond India's borders. The ODOP scheme preserves traditional craftsmanship, while adding the professional branding and logistics access required to connect local artisans directly to international buyers. This dual-engine approach elevated Uttar Pradesh to the fifth largest exporting state in India. The data shows a broad global reach. The United States buys 19%, followed by the UAE at 8% and the UK at 6%. Exporting both high-end smartphones and handmade carpets creates a diverse portfolio, providing the state with a resilient economic foundation that doesn't rely on a single industry. While the current model has achieved massive scale, it faces a critical bottleneck. Uttar Pradesh is currently a center for large-scale assembly rather than ground-up component manufacturing. The most complex and expensive parts of the devices, like advanced semiconductors and memory chips, are still imported from abroad due to the immense technical and financial barriers to production. True semiconductor fabrication requires multi-billion-dollar investments and an environment capable of engineering materials at a microscopic level. The next phase of industrial policy aims to overcome this by using advanced production-linked incentives to attract the manufacturing of raw components, such as battery cells and chips, directly to the state. The physical infrastructure and the massive trained workforce established over the last several years serve as the mandatory foundation for this next technological step. Successfully transitioning from final assembly to native component manufacturing would bridge the gap between being a regional export node and becoming a primary manufacturing hub, positioning the state to compete with the world's leading industrial centers.